Hello everyone, here we start with exercise 22b of trigonometric ratios. In question number 2, we have been given with a figure in which a triangle ABC and ABD is there with a common side AB. Then two of the sides also been given, and then we have been given with the two angles. First of all, we have to find the sides, this side AC and this BD. And here we have placed a Pythagoras theorem in the triangle ABC and got AC as 10. Now we are going to plot a Pythagoras theorem in triangle ABD. Now by using Pythagoras theorem in triangle ABD, we have got AD square equals to AB square plus BD square, in which the BD is to be calculated, and we have placed all the values, and then on making a transpose we have got BD square as 225, and on taking square root on both the sides we have got BD as 15. Now in the first part we have been asked sin x, and sin x is perpendicular upon hypotenuse. So for the x, perpendicular will be AB and the hypotenuse will be AD. Then we are having cos y. Cos y is base upon perpendicular. For the y, this one will be base and this will be a perpendicular. So hypotenuse, base upon hypotenuse. Here AC is hypotenuse. So we've got this. Now the third part. Now here we have the question 3 tan x minus 2 sin y plus 4 cos y. So for the x, this is the base, this one is the perpendicular. So this can be written as 3 into perpendicular upon base. Tan x is perpendicular upon base. So AB upon BD minus 2 into sin y. Sin y means perpendicular upon hypotenuse, that is AB upon hypotenuse AC. Then plus 4 into cos y, that is base upon hypotenuse, that is BC upon AC. Now we are going to place the values. On placing the value and solving it, we have got this. Then these two can be cancelled out and we will be left with 12 upon 5, that is equals to 2 whole 2 upon 5. Now in question number 3, we have been given with a right angle triangle ABC in which two of the sides have been given to you. Then a perpendicular is dropped from here. This means this triangle is also a right angle triangle and this one is also a right angle triangle. So overall we are having 3 right angle triangle over here. With the help of these two, we will be able to find this whole. Then with the help of those, we have to find this side BD as well as the CD and AD. So let's first of all find AC. With the help of the Pythagoras theorem, we have got AC as 13 centimeter. Now as we know, this whole AC is 13, and if we take this CD as x, then this will become 13 minus x. Now with the help of this, we are going to find the value of BD in the terms of x. Now on using Pythagoras theorem in triangle ABD, we have got AB square equals to BD square plus AD square, and after placing the value, we have find the value of BD square as 144 minus 13 minus x to the whole square. Now the same we are going to do for the BCD, and again we are going to find the BD square from there. Now here we have got BD square equals to 25 minus x square. Now we are going to equate both of the equation because in both the cases LHS is BD square. Now we are going to solve this one after rearranging, and then using the identity of a minus b to the whole square, we have got this expression. Here this x square will be cancelled with this one. Then we are going to transfer this on the other side. Now after making a transpose and all, and finally we get the value of x as 25 by 13. Now we can find the value of BD with the help of either this equation or this equation. So I am preferring this one. Now on placing the values and solving it, we have got 60 upon 13 as the BD value. Now here in the first part we have to find out cos angle DBC. So for the angle DBC, that is this angle, this will be the base and this will be the hypotenuse. So cos DBC can be written as BD upon BC. Now place the values of both. BD we are having 60 by 13 and BC we are having 5. This 5 can cancel. First of all, write this one as 60 upon 5 into 13. This 5 can cancel this one and it will become 12, and that is 12 upon 13. And the next part is cot angle DBA. So here for the angle DBA, this one is a base and this one is a perpendicular. Cot is base upon perpendicular, so it will be BD upon AD. Here we know the value of BD as 60 by 13 and AD we have to calculate. So let's calculate over here only. And we have got AD as 144 by 13. After placing the value, we can cancel the denominator of both of the numerator and denominator. So this 13 is cancelled by this one. Now the both can be divided by 12 and it will be 5 and 12. Hence 5 upon 12 as the answer. Now in question number 5, we have been given a triangle ABC in which AB equals to AC equals to 15 centimeter and BD is 18 centimeter. Now we have to find the value of cos angle ABC, cos of angle ABC. For that we have to take a perpendicular from here. Now here we have got a perpendicular AD from A to BC. Now as we all know that it is an isosceles triangle, and in isosceles triangle perpendicular from the terminal angle bisects the base angle, base side. Therefore BD will be half of BC. Now here we get BD as 9 centimeter. Now cos angle ABC can also be written as cos of angle ABD, and this will be base upon hypotenuse, that is BD upon AB, and the base is 9 and this hypotenuse is 15, so this will be 3 upon 5. Now let's see question number 7. In this question we have been given with a triangle with the one side BC and the angle, and here the tan x is given as 3 upon 4. As we all know, tan x is perpendicular upon base, so therefore we can take perpendicular as 3x and the base as 4x. And here perpendicular is BC and the base is AB, so we can also write BC upon AB to equals to 3 upon 4. Now we have supposed BC equals to 3x and AB equals to 4x. Now we have been given that BC equals to 15, so we can equate this 3x with this 12 and this 15. And on placing the value, we have got the value of x as 5. Now we can easily find the AB. So here we got AB as 20 centimeter. Now with the help of this AB and BC, we can find this AC, that is by Pythagoras theorem. And applying a Pythagoras theorem, we finally get AC equals to the root 165, that is equals to 25 centimeter. Now let's see question number. In question number 8, we see we are having this figure. Now with the help of this two sides, we will be able to find out this one. Now to get this side or the other, we have to draw perpendicular from here as this one, let this one be E point. Now if this is 12 and as all of them are perpendicular, this means it is a rectangle and it will be 12. Now very first of all we will finding this side CD, and the side CD will be equals to side EB, and if we get the EB we can find AE. Now let's start with this. And with the help of the Pythagoras theorem, we have finally got CD. And now BE will also be equals to equals to 5, and therefore this AE will be equals to 14 minus 5, that is 9. For the first part, we have to find the value of sine phi. Phi is just a symbol as we use for the theta. Now here the sine phi means the perpendicular upon hypotenuse. So for this phi, this CD is perpendicular and BC is hypotenuse. So this can be written as CD upon BD. CD we have just calculated as 5 and BD we are having 13. Then we have to find tan theta. For the theta, this one is perpendicular, this is base, and this one is hypotenuse. As the tan is perpendicular upon base, so it will be ED upon AE. That is 12 upon AE we have got 9 equals to 4 upon 3. Now in the second part we have to express AD in the terms of theta. So as we see that for the theta this is a hypotenuse. So either we take a cos theta or a sin theta. If we take sin theta, then sin theta is perpendicular upon hypotenuse, that is ED upon AD. Now place the values. ED we are having 12 upon AD. Now take a cross multiplication and you will be getting AD equals to 12 upon sin theta. Now this can also be written as AD equals to 12 as the reciprocal of sin theta is cosec theta. And here is the solution for this one. Here we have been given with sin A plus cosec A, and that is equals to 2, and we have to find the sin square A plus cosec square A. So we are going to take the square on both the side of this one. Then expanding by using the identity of A plus B to the whole square. Here sin A and cosec A are the reciprocals of each other, and as they are multiplied they will be cancelling out each other. So finally we are left with the 2 answer. Here in the cos A, in the question of 14, we have been given 5 cos A minus 12 sin A equals to 0. And we have to evaluate this value. First of all, we are going to rearrange this one as 5 cos A equals to 12 sin A. And then we can bring a cos A over here and the sin and 12 over there. That is sin A upon cos A equals to 5 by 12. That is tan A equals to 5 by 12. Now we have to find out the value of this one. So we can divide each of the term in the numerator as well as in the denominator by cos A. And after doing so, we can cancel out this cos A by cos A and then this cos A by this one. Then we know the value of sin A upon cos A, that is 5 by 12. So we can place 5 by 12 minus 1 whole upon, this will be 2 minus 5 by 12. We have just placed the value of sin A upon cos A over here. Now we are going to simplify it by taking LCM in the numerator. So here it will be 12 and it will become 5 minus 12, and here again you will be getting 12 as LCM, and this will become 24 minus 5. Now we can cancel this 12 by this 12 and we will be left with minus 7 upon 19. So here one correction that we have to place a plus sign over here because it was plus. So plus over here, plus, and then we have to add to get 17 upon 19 as the final answer. Now here in question number 15 we have been given with a triangle ABC, and since that the C is having a 90-degree over here and the D is midpoint of AC, and as D is midpoint of AC, the CD will be half of AC. Now we have to find out tan angle CAB upon tan angle CDB. For the angle A, this will be the perpendicular and this will be the base, and for angle D, this will be the perpendicular and this one will be the base. So the tan CAB can be written as BC upon AC and BC upon CD, and on rearranging we get BC into CD upon BC into AC. Here we can cancel this BC by BC and we'll be left with CD and AC. Now this CD can be replaced by AC by 2 as we have got over here, and then rearranged as this one. Here this AC can be cancelled by this AC and we are left with 1 upon 2 as answer for this part. Here we are having tan angle ABC and DBC. For angle ABC, that is this whole, this will be the perpendicular and this will be the base, and for the DBC, that is for this much only, this is perpendicular and this whole is base. After placing the value and rearranging, we have got this one where this BC can be cancelled by this, and here AC and DC are there, so AC upon this CD can be replaced by AC by 2, and it can be further written as AC into 2 upon AC. Here it is cancelled out and we are left with 2 as answer for this part. Now here in question number 18 we are having a rhombus in which the diagonals AC and BD bisects at O, and the length of OB is been given to us as 8 cm, and the cosine of CAB is been given as 0.6. Now as cosine of CAB, that is base upon hypotenuse. So for here the base is AO upon AB equals to 6 upon 10. We can solve them and get 3 by 5. Now let AO equals to 3x and AB equals to 5x. Now in triangle AOB, by Pythagoras theorem, AB square will be equals to AO square plus BO square. And now we are going to solve to get the value of x. On solving for the x, we have got finally the value of x as 2. Now therefore this AO equals to 3 into 2, that is 6 centimeter, and AB equals to 5 into 2, that is 10 centimeter. Now as we have to find the diagonals and the sides of a rhombus, so here BD is equals to twice of BO, as diagonals of rhombus bisects each other. And hence it will be 2 into 8 equals to 16 centimeter, and similarly we will be getting AC. Then the sides, As all of the sides of the rhombus are equal to each other, therefore all of the sides will be of length 10 centimeter. That's all for this question. Now we'll go for question number 21. Now here we are having the question in which q tan A equals to P, and we have to find the value of this expression. So first of all we are going to find the value of tan A from here. So tan A will be equals to P by Q. Now as we know that tan A can be written as sin A upon cos A, therefore sin A upon cos A will be equals to P by Q. Now we'll go for the question part which is to be founded. Here we are going to divide both the numerator and denominator by cos A. After doing so we can cancel out the cos and here. After that we place the value of sin A upon cos A, that is P upon Q, and then take the LCM. Then we can solve them and we will be left with P square minus Q square upon P square plus Q square. Now let's see question number 28. Here in this question we have been given 5 cos theta equals to 3, and it can be written as cos theta equals to 3 by 5. Now let's go for the part which is to be calculated. Here this can be written as 1 upon sin theta minus cos theta upon sin theta. Cosec is replaced by 1 upon sin theta, and cot is split as cos theta upon sin theta in the both numerator and denominator. Now we can see that we are having sin theta common in both of it. So we can take 1 upon sin theta common in the numerator as well as in denominator, and by doing so we get 1 minus cos theta, and here 1 upon sin theta taken common, so you will be left with 1 plus cos theta. Now they are cancelled out. Now we'll place the value of cos theta. After placing the value and taking LCM, we have got this. Then here both the denominators can be cancelled out and we're left with 5 minus 3, that is 2 upon 8, and that is equals to 1 upon 4. That's all in this video. Thank you.